All right, so good morning. We're going over 1.2 graphs of equations in two variable circles. So let's start with example 1, which is sketching a graph by plotting the points. So you sketch a graph of the equation. We have 2x minus y equals to 3. It is rearranged into y equals 2x minus 3 in the chart. We did that by subtracting the 2x on both sides, which left me with negative y is equal to negative 2x plus 3. And then we multiplied everything times negative 1, which gives us y is equal to 2x minus 3. That's how we rearranged it. Now, let's find the points that they're asking us, and then they want us to graph it. So we have negative 1. So we're going to plug in 2 times negative 1 minus 3. We're plugging in for the x, which is going to give us our y. So this is going to be negative 1, comma. And we're going to solve it by doing 2 times negative 1 is negative 2. Negative 2 minus 3 is negative 5. We do the same thing for 0. 2 times 0 minus 3 is going to be 0, comma. 2 times 0 is 0, and then 0 minus 3 is negative 3. Then we have again 2 times 1 minus 3. 2 times 1 is 2. 2 minus 3 is negative 1, so we're left with 1 comma negative 1. We have 2 times 2 minus 3. That's going to be 2 times 2 is 4. 4 minus 3 is 1, so we're left with 2 comma 1. We have 2 times 3 minus 3. It's going to be 2 times 3 is 6. 6 minus 3 is 3. And then lastly, we have 2 times 4 minus 3. We're left with 2 comma. 2 times 4 is 8, minus 3 is 5. So here are the points that you would plot. Now, if you remember how to graph with right over wrong, you're also able to do that. It's just two different ways of doing it. So let's say we have this graph. Bear with me because I know it's not perfect. We have a point at negative 1, negative 5, which is right here, at 0, negative 3, at 1, comma, negative 1, at 2, comma, 1, at 3, comma, 3. Sorry, the last one should have been 4, comma, 5. I don't know why I wrote 2. Let me rewrite it, 4, comma, 5, which is up here. That gives us the line of the graph that we're graphing. That's if we do it with the point. If you guys remember how to do right over run, you know that negative 3 when we rearranged it is the y-intercept right there. And then we can rise 2, so up 2, and we run 1. Up 2, and we run 1. And that's how you also can get your points. Intercept. So the x-coordinate of the points where a graph intersects the x-axis are called the x-intercepts of the graph and are obtained by setting y is equal to 0 in the equation of the graph. And then the y-coordinates of the points where a graph intersects the y-axis are called the y-intercepts of the graph and are obtained by setting x is equal to 0 in the equation of the graph. You remember, I don't remember if it's 1.2 or in chapter P. We went over the quadrants, and I mentioned that the axes are not part of the quadrants because you're going to get an x comma 0, a negative x comma 0, 0 comma y, 0 comma negative y. Those are all the intercepts as well. If you have a 0 for the y, you will have an x-intercept. If you have a 0 for the x, you will have a y-intercept. This ties in with what we talked about in the quadrants. I'm pretty sure it was 1.1, but it may be wrong. It may be P6. But I'm 95% sure it was 1.1. So if you have an equation like the last equation, which is y is equal to 2x minus 3, if we want to find the y-intercept, we're going to set the x to 0. So we're going to get y is equal to 2 times, we set the x to 0. So you don't have to even graph it. Minus 3, so y is equal to 0 minus 3. So your y-intercept is negative 3. So it would be 0 comma negative 3, because that's also the point you plugged in for x. if you wanted to find the y-intercept of that same graph, we plug 0 for the y. And we get 2x minus 3. So we add the 3 on both sides, and we get 3 is equal to 2x divided by 2. And we get that the y-intercept is 3 over 2, or 1.5. So your point for the x-intercept would be 3 over 2, comma, 0. All right, so for this one, let's plug in the numbers. We want to figure out the y's, and we want to figure out the x's. The x's are all given to us right here. So we don't have to figure out. We already have all of the x's here. We have -3, comma, whatever, -2, comma, whatever, -1, 0, comma, 1, comma, 2, comma, and 3, comma. Let's pretend I can write in a straight line, and that's stayed in the same place. So we have all of the x's of those ordered pairs. Now let's find the y's. We plug this in, we're going to get y is equal to -3 squared minus 2. Now keep in mind that -3 has to be in parentheses because you're multiplying -3 2 times. So you're going to get 9, and 9 minus 2 is 7. So there we found the second point. We're going to do it here as well. -2 squared minus 2. -2 times -2 is 4. Minus 2 is 2. We found the second point. -1 squared minus 2. 1 times 1 is 1. Or -1 times -1 is 1. Minus 2, -1. We have 0 squared minus 2. 0 squared is just 0. Minus 2 is -2. Then we have 1 squared minus 2. So 1 squared is 1. Minus 2 is -1. Then we have 2 squared minus 2. So 2 times 2 is 4. Minus 2 is 2. And then we have 3 squared minus 2, which is 9. Minus 2 is 7. So here we have all the ordered pairs. Okay, so if I were to graph this, again, estimate of kind of where there should be. So -3, 7. So up there. Then -2, 2. Then -1, -1, 0, -2. 1, -1, 2, 2, 3, 7. So here we have a quadratic graph. We knew it was quadratic because this x is squared anyway. But your graph should look similar to that. Again, if you use graph paper, it'll make it easier. Now for the other one, it's an absolute value graph. We see this because of the absolute value symbols. So it's going to be the absolute value of -3. So our x is -3, 3. I'm just going to write all of the x's. Okay, so then the absolute value of -2 is 2. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 again is 1. The absolute value of 2 is 2. And the absolute value of 3 is 3. So when I go to graph this, we're going to put -3, 3. Right there, -2, 2. -1, 1, 0, 1, 2, and 3. So here we get an absolute value graph. So intercepts, 2 of 2. So definitions of intercepts. The x-intercept is the x-coordinate of the point where the graph of an equation intersects at the x-axis. So that's when y is equal to 0, and you solve for x. So what we did in the previous intercept slide. So we also have different types of graphs. For example, here we have a cubed graph, and we get 1, 2, three x-intercepts. You'll be able to find them because in the equation it'll be a cubed. The amount of the exponent, so if it's x to the first power, it'll be 1. If it's x to the second, it'll be 2. If it's x to the third, it should be 3. Now, depending on the translation of the graph, up, down, sideways, flipped, rotated, you may not have all of those. But usually if they're not rotated or anything, you should get that amount of intercepts. That's the amount of x's you're going to get. And for example, in the y, we also have a cubed, just flip sideways. So now we have 1, 2, and then if the line kept going, we would have a third one right there. Now the graph kind of cuts off right there, so we don't have a third one. So again, it just depends on the type of rotation translation that the graph has. The y-intercept is the y-coordinates of the point where the graph of the equation intersects the y-axis. So you set x is equal to 0 and solve for y. So exactly what we did in the other intercept slide. So to find the x and the y-axis for the y is equal x squared minus 2, the first thing I'm going to do is I want to find let's just say I want to find the x-intercept first. So to find the x-intercept, we want y to equal to 0. So we're going to do 0 equals x squared minus 2. I'll add the 2 on both sides. And I'll get 2 is equal to x squared. When I take the root, I'm going to get that it's going to be plus. So our x-intercept is going to be plus or minus root 2. That's going to be root 2 comma 0. And negative root 2 comma 0. Now to find the y-intercept, I will get the x equal to 0. So y is equal to 0 minus 2. So we get y is equal to negative 2. So our y-intercept is just 0 comma negative 2. So those technically are your answers. Notice how we had a squared and we got 2 x's. It's something that it's going to happen quite often. The amount of x's the exponent is, the amount of x's you will get. Again, this is the rule. There's always exceptions, but it's something to keep in mind. All right, I'll start 49. I'll do it in red. Hopefully they won't collide. So 49 is y is equal x squared minus 5. If I want to find the x-intercept, again, I get the y equal to 0. So we get x squared minus 5. I add the 5, and I get 5 is equal to x squared. When I take the square root, I get that x is equal plus or minus root 5. So again, we get positive root 5 comma 0 and negative root 5 comma 0. And if I'm looking for the y-intercept, I'll get y is equal to 0 squared minus 5 to y is equal to 0 minus 5. Y is equal to negative 5. So our y-intercept is 0 comma negative 5. Again, this 3 order pairs being your answer for the x and the y-intercept. So for 51, I'm going to look for the x-intercept first. So everything that's to y will become a 0. So 0 minus 2x times 0 plus 2x equals 1. So 0 minus, this is going to cancel out to become 0. Plus 2x is equal to 1. So we can ignore this left side just because it's 0 and 0 doesn't do anything for us. So we're left with 2x equals to 1. I'll divide by 2 on both sides, and we get x is equal to a half. So my x-intercept is a half comma 0. And then for the y-intercept, I'm going to plug in 0 everywhere there's an x. So y minus 2 times 0, y plus 2 times 0 minus 1. Everything that has 0 cancels out. So I'm not going to rewrite it because it's just going to be y minus 0 plus 0, which is not going to do, again, anything for us. So we're left with y is equal to 1, leaving our y-intercept as 0 comma 1. Again, this being your final answer. For 53, again, I'm going to start looking for the x-intercept. So we get 0 equals root x plus 1. Now to get rid of that root, I'm going to square both sides, which is just going to give me 0 is equal to x plus 1. I'll subtract the 1, and we get x is equal to negative 1. So our x-intercept is negative 1, 0. And I'm also looking for the y-intercept. So it's going to be y equals root 0 plus 1. So y equals root 1. Root 1 is just plus or minus 1. So we get a y of 0, 1 and 0, negative 1. The reason it's plus or minus 1 is because the square root of 1 is just 1. But if you have negative 1 times negative 1, it gives you 1. And 1 times 1 gives you 1. So that's why it's a plus or minus. All right, and for 55, we're going to do the exact same thing. For the x-intercept, we get 4x squared plus 25 times 0 squared equals 100. Again, 0 squared is 0 and 25 times 0 is 0, so that term disappears, cancels out. So we're left with 4x squared equals 100. I'm going to divide by 4 first, and that's going to give me that x squared is equal to 25. So when I take the square root, I will get x is equal to plus or minus 5. So our x-intercept is 5, 0, negative 5, 0. We're going to do the same thing for the y-intercept. We're left with 4 times 0 squared plus 25y squared equals 100. Again, the 4 times the 0 cancels out because 0 times anything is 0. So we get 25y squared equals 100. I will divide by 25 on both sides, and that'll give me y squared is equal to 4. When I take the square root, I get y is equal to plus or minus 2. So our answer is 0, 2 and 0, negative 2. So you have 2 x-intercepts and 2 y-intercepts. So here we have the equation of a circle. An equation of a circle with center h and k and a radius r is, we have the formula x minus h squared plus y minus k squared equals r squared. And that is called standard form for the equation of a circle. If the center of the circle is at the origin, so at 0, 0, the equation of a circle is just x squared plus y squared equals to r. So I'm going to go ahead and write the formula up here so we don't forget it. X minus h squared plus y minus k squared equals r squared. So they want us to work on these problems. For 67 through 72, they want us to find the center and the radius of the circle and sketch the graph. Now, I'm not going to sketch the graph because, again, I don't have graph paper, and it's kind of harder to sketch a circle. But to find the center and the radius, we can do. So for 67, our center is, since we have x squared plus y squared, our center is at 0, 0. And then our radius would be at 3. Why 3? We take the square root of 9. So your radius is always going to be the square root of whatever the number is by itself on the right. For 68, we have the center, again, at 0, 0. And then the radius is going to be root 5. For 69, we have negative 3 for the x and 0 for the y. So it's always going to be the opposite sign. So if we have negative 3, it's going to be at positive 3. Getting comma 0 because our y doesn't have a number with it. And then the radius is going to be root 16, which is going to be 4. Now, the reason I'm only taking the positive is because when you have a circle, the radius is going to be 4 in this case, no matter which way you draw it or in what direction, because the radius is the same distance from the center to the outer edge. Now, for 70, we have 0, 2 for the center, and then the radius is going to be 2. Again, the square root of 4. For 71, we have positive 3 and negative 4. So our center is going to be the opposite signs, negative 3, comma 4. And then for the radius, it's just 5, because root 25 becomes 5. And then for the last one, we have positive 1 and positive 2. So our center is negative 1, comma negative 2. And the radius is root 36. Root 36 is 6. For 73 through 80, so just 73, 74, and 75 in this case, they want us to find the equation of a circle that satisfies the given conditions. So we're going to grab that equation I wrote at the top right there in red, and we're just going to plug the numbers in. So for 73, they're telling us that center is at negative 3, 2. So we're going to plug in x minus negative 3, all that squared, plus y minus 2, all that squared. And they're telling us the radius is 5, so we just do 5 squared. So this is going to give us x, again, negative, and then minus 3 is going to become a positive. So x plus 3 squared. Then we have y minus 2 squared. And then 5 squared is just 25. So there, we have the equation of the circle. Again, this would be your final answer. For 74, it's the same idea. We have the center at negative 1, negative 3, and a radius of 3. So for 74, again, we're going to plug in x minus negative 1 squared plus y minus negative 3 squared equals 3 squared. Now, if you know they're already going to flip the signs because a negative and a minus negative becomes positive, you don't have to plug it into the equation and then flip it. I'm just doing it in the case that you prefer to, as that way you may not make as many silly mistakes. So you get x plus 1 squared plus y plus 3 squared equals 9. Again, this would be the final answer. For 75, it's a little different. They're telling us the center is at the origin, so 0, 0. And they're telling us that it passes through the point 4, 7. So they're not telling us the radius. We have to use a distance formula to find this radius because we don't know. Well, that doesn't look like it is exactly a straight line because we don't have a 0 in there. So we're just going to go ahead and use a distance formula. So the radius is the distance formula x2 minus x1 squared plus y2 minus y1 squared. So the radius is, I'm just going to choose these to be my 2's and these to be my 1's. So I chose my 4 and 7 to be my 2's and my 0, 0 to be the 1. It's going to be 4 minus 0 squared plus 7 minus 0 squared. So the radius is 4 squared plus 7 squared. That is 16 plus 49. So my radius is the root of 65. I'm not going to simplify it, and you're going to see why in a moment. So we know the center is 0, 0. So I'm just going to go ahead and plug in the formula. X minus 0 squared plus y minus 0 squared equals root 65 squared. The zeros disappear, so I'm left with x squared plus y squared. The reason I didn't simplify the root 65 is because when I simplify, notice how I have root 65 squared. The root and the square are going to cancel each other out, so I'm just going to be left with 65. So this would be your final answer for this problem. So here they want us to find an equation of a circle and find an equation of the circle with the radius 3 and a center 2, negative 5. So they already tell us the radius and they already tell us the center. So for A, I'm just going to go ahead and plug in x minus 2 squared plus y minus negative 5 squared equals 3 squared. So our formula for this, the equation for the circle is x minus 2 squared plus y plus 5 squared equals 9. So there, here we already answered A, and you keep going. For B, they want us to find an equation of a circle that has points 1, 8 and Q 5, -10 as the endpoints of the diameter. So we're going to have to figure out what the center is and what the radius is. So to find the center, we're going to use the midpoint formula. So we're going to do 1 plus 5 over 2, 8 plus negative 6 over 2. So our midpoint is going to be 6 over 2, 2 over 2, which is just 3, 1. And then for the radius, I'm going to choose the points that I found for the midpoint, which that would be our center. and just choose the same thing I did before. So the radius is going to be 1 minus 3 squared plus 8 minus 1 squared. Now I use the midpoint and point P for the distance formula. I could have used the midpoint and point Q, or I could have used the distance formula for P and Q and just at the very end divide by 2, and I would still get my radius. The reason I'm doing it with the radius is so I can ignore the last step of dividing by 2. And if I have a square or something, I can just leave it the way it is. So our radius is going to be negative 2 squared plus 7 squared. So it's going to be, I'm going to go here, radius equals 4 squared plus 49. Sorry, not 4 squared, 2 squared, which is 4. Under the square root, so our radius is root 53. So for our equation, I can just go ahead and plug in x minus 3 squared plus y minus 1 squared equals root 53 squared. So I get x minus 3 squared plus y minus 1 squared equals 253. This being your final answer. So we have different types of symmetries. With respect to the x-axis, we replace the y by a negative y. And if the resulting equation is equivalent to the original one, we get x-axis symmetry. Now with respect to the y-axis, we replace an x with a negative x. And if the result of the equation is equivalent to the original one, then we have symmetry with the x-axis. And with respect to the origin, we replace a x to a negative x and a y by a negative y. And if the results of the equation is equivalent to the original one, then we have symmetry based on the origin. So notice how for the x, the graph is unchanged. So if you draw a line down this middle, we have, basically you can fold it over itself. Same for the y. If we draw a line of symmetry down the y, we can fold the graph on top of each other and it would be the same. And then for the axis of symmetry, it looks the same, it's rotated 180 degrees. So if you can use your imagination, just rotate one of those axes about that line and you'll get the exact same graph from the other side. So they want us to test the equation x equals y squared for symmetry and sketch the graph. So I'm going to write symmetry with respect to the x-axis. I misspelled that, it's 2 M's. Symmetry. With respect to x-axis, we have symmetry with y-axis and symmetry with respect to origin. Or, if you could think about it, x and y-axis. So, let's test out the symmetry with the x-axis. So, we're going to do x is equal to negative y squared. If I were to square that negative y, I'm going to get x is equal to y squared. So again, the reason we don't get rid of the square is because technically it's not the equation, but we have to see how it would affect the variable. We get x is equal to y squared, which is the same as the original. So we have symmetry with respect to the x-axis. Let's try the y-axis. So if we change the x into a negative x, then y squared. The x stays as negative x equals to y squared. We don't have symmetry with the y-axis because the x doesn't go back to the original. And now if we were to do the x and the y-axis, just to plug it in, negative x equals negative y squared. The x stays negative, the y goes back to the original. So we don't have symmetry along the origin or the x and y axis. Usually if you don't have symmetry for the x and the y, you won't have symmetry for the origin. So just keep that in mind. I'm just doing all of them so you practice. And it depends also on the equation. In this case, since it's a square and it's a simple equation, you'll most likely be able to tell that the y square does change. Alright, so this will be it for today's notes. We went through the whole PowerPoint. You guys have homework on WebAssign. It's not uploaded yet. It will be uploaded by the end of class. But this will be it for today's notes.